Okay, and welcome back to the Turdferg channel. If I ever change this name from Turdferg, this is going to be weird explaining all this. Today's video is truly the art of Kung Fu. We're going to be doing some connected objects questions with multiple objects. Oh, good grief, look at this thing. This is not fair. But anyway, we're going to take a look at doing one like this. Now, that one's a beast. If you can do that one, you rule. Now, we're going to do one like this. It's kind of like the problem you've already done, except it's got this extra object hanging off of it. This one, don't be shocked like in, a college situation to get asked that. That one's not that bad. And then we'll get asked this. So, this one's a little bit funky or whatever. But anyway, we'll see what we can do. First one I'm going to do. And I'm not saying I'm going to work all of these. If you want to work the problem, then go ahead, because you can watch this video even, and there's the answers that should be to this question, assuming you can read this on YouTube, which I don't know that you can. I only know if this camera is focused because my screen's so small. But anyway, I'm going to first take a look at this picture. Now, here's the thing. You've got 1, 2, 3 masses. That means I need 3 free body diagrams. So that's what I'm going to do first. I'm going to first start out by drawing 3 free bodies. And then for every free body diagram, I'm going to go back and do a sum of the forces on each one of those. So here's 1, there's 2, and, whoa, I'm getting really crooked here. And here is my third free body diagram. Alright. So now, as I do these free body diagrams, I'm going to take a look. I wish I had like a little better something to write with here, but maybe I can just use a plain old Expo marker here. But let's do M1 first. M1, we see a rope coming off the top of it. So M1, I've got a rope coming off the top, and I'm going to call that T1 coming off the top. And then we've got coming off the bottom, and M1G coming down off the bottom of it. So there's my first object, number 1. Now, that one's not hard. You're used to that. The one that's going to trick you is now this M2, this object up here. So we've got this other object right here, M2. And let's do our diagram for it. It's got a rope attached to the top of it. So for it, come back in here, we've got a T1 coming off the top. It's that same tension. You see, this rope and this rope is the same piece of rope. If you're wondering why I called this T1, that's because in this problem there's going to be a T2. Every piece of rope is going to be a different tension. So I've got a T1 up here and a T1 up here. This M2G also has an M2G going down. So let's draw our M2G down. But here's the thing. There's also a rope attached to the bottom of this second object, which means there is also a T2 down on this one. So that's where this one comes in. You've got an M2G down, plus there's a rope. Well, the same rope attached to the bottom of this object is the same rope that's attached to the top of the third object. So this same T2 is the same T2 over here. And then we've got on this third object, it's also got, like every object, an MG. But since this is our third object, it will be M3G. And at this point, we've got everything we need to start working this problem. We can start doing our sum of the forces. Every one of these will be a sum of the forces Y. So sum of the forces Y. For this one, T1 minus M1G equals M1A. So that's got this object taken care of. Now, let's move on to this object. This object, sum of the forces Y, I'm going to stagger these a little so that I've got room to write. Sum of the forces Y. For this object, we've got the T1 up. Then we've got minus T2 and minus M2G equals this object is falling. This object, I think, hold on, I may be wrong. Let's look at this. I may have already screwed this problem up. M1 it says, alright, it says that, nope, we're good. It says that this is 5 and this is 4.2 and that's 3. So it's pretty clear that these are going to be falling, this one's going to be going up. So, okay, we're doing this problem right. I'm not going to worry too much about this. So I know that this object's falling down, so I'm going to set it equal to negative M2A. And now for the third object. I've got T2 going up, sum of the forces Y, and this is for my third one. It would be T2 minus M3G equals, this one is also falling, it's moving down, so I'm going to set it equal to M3, negative M3A, and the physics in this problem is 100% over. And I'm not going to work this out all the way. I should get you close to the point. So you should be able to finish this now. I would solve this equation for T1. T1 is equal to, what would it be? M1A plus M1G. So there's my T1. I would solve this one for T2. T2 would be equal to M3G minus M3A. And now I would do this. I would take this T1, plug it in there, and then take this T2 and plug it in here. And so now our final algebra before we actually finish this, that T1 would be M1A plus M1G. Now, this is going to mess some people up. When you substitute this, look, you're substituting for negative T2. So this becomes negative M3G, and negative M3A, which means what's negative times negative when you substitute. This becomes positive M3A, now minus M2G, equals negative M2A. This is a beautiful question. And what you're going to do, everything with an A comes to this side. And you're going to end up, when you do your algebra, you're going to end up with A times M1 plus M2 plus M3. The other side, there will be a G that will factor out. And on the other side, it looks like there will be M2, let's see, plus M3, and then minus M1. And this is the way the other side will end up looking. You can plug in your numbers and get your answers. And the answers, if you go back and watch at the beginning of the video, the answers are in there. At this point, all you got to do is substitute numbers. All right. So there we've got this object. And this is, I mean, I think a lot of teachers would ask you a question like this because it's got multiple tensions in it, and it's not that hard. It's nice and clear because there's no angles in that. And that's what really makes that good. I'm trying to decide which one I'm going to do next because both questions are actually pretty hard. I'm going to do this one. I'm probably going to make a separate video on the other one. I think it would classify as more of a Buick than this one even. And although both of them are actually pretty hard questions in terms of having multiple objects. Let's take a look, though, at this one. This is a pretty hard object. So I've got 1, 2, 3, and I think what's happening is this weight is falling, and that's important to know. Because I need to know that this is falling. I need to know that this one's moving to the left, and that one is also moving to the left. That tells me something. When I do my MAs and all that kind of stuff, the sum of the forces I have for this one is going to be equal to negative M1A because it's falling. My sum of the forces X for this one is going to be negative M2A because it's moving to the left. And then this one over here is going to also be negative M3A because it's moving to the left. So all my sum of the forces in this one are going to be equal to negative MAs. So before we get carried away, though, we need 3 free body diagrams, and that's what makes this one so hard. So let's come back here. Let's start this off. 3 free body diagrams. So 1, and there's really nothing I can do entertaining while making X's on my paper. Maybe if I was a better, more prepared teacher person, I would have done this in advance. But the reality of it is, it's been actually quite a hectic day today. Actually managed to smoke the entire building up, which even for me was an accomplishment. All right, so I've got 3 objects, and I'm gonna label what these are up at the top, because this thing, it's a house. So I'm gonna sit here. This is gonna be my M1, and it's 10 kilograms. This is gonna be my M2, and my M2 is 5 kilograms. And then this is my M3. Oddly enough, it is 3 kilograms. So I need to do a free body diagram now on each object in that picture. I'm going to do the one hanging off the edge first. I love this one. It's the easiest. I've got, on this one, there's a rope attached to the top of it. So I've got a tension coming off the top that I will call T1. And again, I call it T1 over here. I've got 2 ropes, so this rope is my 1. This rope over here will be my T2. Let's go back to this one. You've got the tension 1 coming off the top, and you've also got a M1G coming off the bottom of it. And that's it for this object. Now let's go over to this object over here. Now, the part about this that makes it hard is it said that this surface is rough. What's the significance of that surface being rough? And both of these are on rough surfaces. That means that there is a friction present working against each of these objects. So now, let's do a free body on this one. Let's do the obvious things first. There's going to be, going down, an M2G. It's sitting on top of something, so that means that there is a normal force in this problem. Now, this is where you got to be careful. There's a rope attached to the left, so that means to the left, I've got a T1. Now, there's a rope attached to the right. Whew, getting confusing. Which I will call T2. Sorry, not the best looking T2 in the world. But anyway, so I've got T1 here and a T2. If anybody ever wants to buy me better markers, that'd be great for this. This is the thing. Not only is there a T2 going backwards on this, since this is rough and it's moving to the left, there's a friction, a mu, and I just thought of something, mu N1, and I'm going to call that N1. If you're wondering, why am I doing the N1s here? This is because this object and this object are going to have 2 different normal forces. Excuse me. Now for the last object. Now, when you do your object on this last one, what it would do when it's setting on that hillside, you would have a normal force going straight up. There would be a tension going to the left, a mu n going backwards, and a mg straight down, which means that mg is going to be at an angle. So now we need to get this rough free body straightened out and put over here. So we're going to have, in this photo, we're going to have an N2. We're going to have a T2. We're going to have a mu N2. Good grief, this is crazy. And then there's also going to be, check this out, an M3G But M3G is at an angle of, let's see if I can read this, 25 degrees. And I'm going to write it with something else a little smaller. 25 degrees is my angle. Holy cow. There it is. 3 free body diagrams. So now all I need to do this problem is to write a sum of the forces for each one of these. Whew! My goodness. Someone is crazy. Who thought of this? Alright, let's do this one. Sum of the forces Y. It'll be the easiest. Sum of the forces Y would be equal to, for this one, T1 up, T1 minus M1G. It is, we already discussed, it's falling, so it is equal to negative M1A. Woo, goodness. Now, let's do our sum of the forces X and Y for this one. Good grief. Sum of the forces X, sum of the forces Y. Take a look at this one. To the right, I've got a T2 and a mu n1. So, T2 plus mu n1 minus T1 equals, this object is also moving to the left, so it's equal to negative M2A. This is going to be like a 20-minute long video. Someone stop me. Then I've got, for sum of the forces Y, I've got N1 minus M2G. This one, luckily, is equal to a 0. And now for the last object. Golly bum. To do a sum of the forces on that. Alright, start out with your positives. I've got 2 positive x's of mu n2 and this M3G sine 25. So now, here we go. Object number 3. Sum of the forces X, sum of the forces Y. So let's see what we can do here. I've got a mu n2 to the right. So we've got mu n2 plus M3G sine 25. And if you're sitting there going, Turdford, why are we using sine for an x? It's because I'm off this y-axis. This is the angle of the hill. 25 minus T2. And this object's moving this way to the left, so it's equal to negative M3A. And then sum of the forces Y would be N2 minus M3G cosine 25. Holy cannoli, cannoli, cannoli. How do you do this question? Well, actually, this is the thing. The physics in this problem is over. 100% over. What you would end up doing with this problem now is simple. You would take this equation, solve for T1. Wow, this is going to be horrific. See what I can sit here and kind of halfway do. So we're going to take that equation, this first one, solve for T1. So T1 would be equal to M1G minus M1A. So there's my T1. I would now go all the way back down here and solve this equation for T2. Let's see if I can do that. T2, let's see, I could just bring the T2 to the right and move the M3 over, and I would have mu N2 plus M3G sine 25 plus M3A equals T2. This is where most people would just give up. But all I've done is added T2 to that side, moved the M3A over. Now the problem is that N2. I'm going to have to eventually substitute m3g cosine 25 in for that n2. Well, it's either now or later. Well, I'll wait a second. Now, what I'm going to do is, now I've got T2 and I've got T1, I'm going to take both of those two equations and I'm going to take them, and I'm going to take T1, plug it back into here, and I'm going to take T2, almost off the paper, and I'm going to plug T2 in right there. And so now, goodness, so in place of T2, I'm going to have mu n2 plus m3g sine of 25 plus m3a plus, that's a horrible looking plus sign, plus mu n1. Yes, we'll have to plug in that n1 eventually. Now check this out, minus T1. So this is going to be minus m1g minus negative m1a, so it's going to be plus m1a, m1a, and all that is now equal to negative m2a. Holy, make your parents watch this video and they might have some respect for what it is we do around here. Check out this beast. I want all the a's on one side, everything without an a to the other side. So I'm going to end up with, when you do this, this is going to end up on the left, I'm going to end up with a times m1 plus m2 plus m3. Because you're to have all positive MAs. And you can look. I am, because I'm going to add this, that, and that. And that lets me know that I've done this problem right when I end up like this. Now, this other side, I'm not going to factor anything out. The other side, I'm just going to get it. This is going to be negative mu n2, negative m3g sine of 25, negative mu n1. Good grief, I'm getting a little suspicious here. Then finally, I'm going to have a plus m1g on the other side. And I think that's right. So negative mu n2, a negative m3g sine 25, a negative mu n1, and then minus m1g becomes positive m1g on the other side. Good grief. Who thought of this? I've still got to plug in my n's. A times m1 plus m2 plus m3 equals, on the other side, negative mu n2, let's see, n2 is m3g cosine 25. So this is going to be negative m3g cosine of 25 minus m3g sine of 25 minus mu times n1. Mu times n1. Good grief. Mu times n1. N1 is just m2g. Thank goodness. G plus m1g. Ah, cool. You can actually factor g all the way out of this. And so our final answer can actually be g times negative mu m3 cosine 25 minus m3 sine 25 minus mu m2 plus m1 equals, and we'll divide everything by the sum of all those. Oh my goodness. I don't even want to look at it. If you've done this problem right, your numbers, M1, where are they? 10, 5, and 3. And according to this problem, the answer to the acceleration, oh, dang, I should have read this problem. It actually says that the acceleration is 2. It wants you to find mu. Well, that's a shame. It was asking you to find that. My advice is it'd be nice if we had a mu and wanted to find a. I'm not redoing this one. This is good. I have solved this equation for a, which is the most typical thing that would be asked. Wow, 25 minutes in. I'm going to bed. Later.